Uh, Assuming that everyone has some sort of programming background, the way I'm going to use this short time is, first of all, I'll discuss a little bit of uh, comparison between Arduino data types and PLC or IEC 611313 type data types that I commonly use. Then I will briefly discuss the scan cycle of Arduino versus the scan cycle of modern PLCs. Then I have a few programs, very small, very brief introductory programs, about 7 of them, which first of all, I will show the circuit in Arduino. I am going to use Tinkercad. Tinkercad is actually an Autodesk product where you can log into a account through a browser, and you can actually simulate Arduino and Arduino circuits. Usually in this kind of session, I take some form of hardware, but because it's a webinar, I can't carry any hardware. What I usually am doing in this session is I will use Tinkercad to show the circuit, show what the output is for that circuit, and then come back and discuss the program. Now, I'll be using 3 different circuits, circuit 1, circuit 2, circuit 3. And for each of these 3 circuits, there are certain programs that I'm going to discuss. Those programs, they are discussed with respect to Arduino, they are discussed with respect to structured text, and they are discussed with respect to ladder program. At any point, if you have any questions, please put it up in the chat box, or you can unmute yourself and interrupt myself. Mohammed Awadullah is the secretary for our New South Wales section, Robotics and Automation Society chapter, and he's also the co-host. So in case I get disconnected for some reason, he will keep this session going. And also, usually what happens in a face-to-face session is for reporting back to IEEE, we get attendee sheet and we put down the name of the attendees. But in this case, because we do not have that, if you can please type in your name and your organization or university in the chat box so that Mohammed can note down, or I may note down after the session is over. Okay, now starting with this data types, I guess everyone has done some sort of programming, so they would be, or like you all would be familiar with integer and floating point data types that we see over here. Now, I guess most of us have done some sort of C-based programming, and int and float are basically the most common types of data that we use in C or C++ or Pascal sort of environment. Now, in IC programming languages, irrespective of what programming language there is no screen visible. Do you see the IC data types on the screen? Okay, thank you. I think if you are in the grid view, you might need to go to the speaker view, or if you are not seeing it, if you can click the visual that is somewhere probably in the grid view. I'm not sure how it works out. Paul, can you see now? Uh, can you try logging back in? If you are using Zoom from PC, you might just quickly try to disconnect and connect back in and see. Okay, in the meantime, let's shortly discuss as Paul tries to join in. Now, irrespective of what kind of program is being used, like IC 611313 discusses 5 types of programming languages. The most common of them is ladder program, obviously. And structured text is one of the best out of the 5 because it helps us write down the program as we do in normal programming languages. There are other programming languages associated, like the instruction list, which is similar to assembly language. And then there are function block diagrams, FBDs, and sorts. But ladder is the programming language that is most commonly used, and structured text is something that is picking up nowadays because of the complexities of automation systems. Now, irrespective of the programming language, if IEC 611313 compliant PLC and PLC programming is being used, we have to sort of rely on these data types. Thanks, Dion. Thank you. And again, like int and real, or LReal, which is like long real, similar to double in C++, C, etc., is most commonly used apart from the bool. Now, because in a automation system, there are a lot of switches and relays, etc., bool is also the most commonly used data type in a PLC environment. Now, I'm not going to go through all the details, but because this is openly available, if you search for IEC 611313 data types, you can easily find this over the internet. This particular table, I have taken it from Farnhill Software website, where it was tabulated quite nicely. And the table for Arduino data types, as you see on the screen, this was from a cheat sheet, which is made by Mark Liffiton. If you look out for Arduino cheat sheet by Mark Liffiton, you will be able to find out a bigger version of this. I just took a snapshot for the data type part. If you don't have any questions from this part, let me move forward. Now, for Arduino-based system, why I'm saying it is Arduino-based, because Arduino is open source. So there is the original Arduino board, or there are many boards which are basically based on the Arduino system. Is the range for int dependent on hardware? No. So if you are using IEC 611313 compliant system, this will be fixed to that range as shown on the board. So this is basically a 4-byte integer. Now, coming to the Arduino-based systems, typically there is a setup which runs only once when the Arduino is started or when a new program is being loaded. The setup function runs once. The requirement of setup we'll see shortly. And then the control is given to a loop, which is similar to a PLC loop, and it keeps on running infinitely. it comes over here when the Arduino is started. Then it goes to the loop and it keeps on looping infinitely. The only time a loop is paused is when there is an interrupt. Now, going back to our undergraduate courses, if we have learned some sort of microprocessor systems, we have learned of interrupts. Now, Arduino allows interrupts, and when there is an interrupt, it will pause the loop, it will run the code given in the interrupt, and then the loop starts running again. In a modern PLC, on the other hand, in traditional PLCs, they are aware, like in old school PLCs, they are aware an option of interrupt. Modern PLCs, to the best of my knowledge, does not allow interrupts. They are typically very fast. They only have the scan cycle, but interrupts or interrupt type of systems can be emulated in a PLC. We'll see how. Typically, a PLC only has a scan cycle that keeps on running over and over here. Now, why there is no setup? Because typically in Arduino, we have to set up inputs and outputs. On a PLC, on the other hand, an input or output is already set up by default. We just have to map the inputs and outputs in our program or in the settings. We'll see shortly. Any questions from this part? Okay. Now on the left, the left pictures are taken from two of the panels I did myself sometime back in the future. The upper part is basically a old school PLC where you have fixed inputs and outputs. So this top part, those were the inputs. On the bottom part, those were the outputs. It cannot be seen properly, but it is kind of fixed. On modern PLCs, on the other hand, nowadays I use backup PLCs quite a lot. The PLC is basically what you see on the left-hand side, the box part I just did. But depending on the requirements, you can buy boxes. So if you do not have requirements for inputs, you don't buy those boxes. So what you see over here, these ones, there are multiple boxes. The first four one over here, they are basically drives. They are compact drives. Then we have, these are like safety terminals, and then there are inputs and outputs. But what I'm trying to say is that these ones, they are basically bought as per requirement. If you don't need inputs, if you don't need outputs, you don't buy them. What you need, you just buy that part. And that is why the inputs and outputs are not fixed. In that sense, what I'm trying to say is you really do not have a fixed number of that input. I'll come to this in more details later on. For Arduino, on the other hand, this is the display of Arduino Uno. Arduino has many other variants like Mega and Nano, but this one is the most commonly bought in schools or in undergraduate courses by the university or other people who are interested in Arduino. They typically buy this one. Now, I'm not going to discuss the analog part in this session, but we'll only go through the digital inputs or outputs. Now, each of these pins, they can be either set as input or as output. That means while While on PLCs, you have fixed ports set for input, or in a flexible type PLC, you need to buy an input terminal or an output terminal separately, but you cannot use an input terminal for outputs, or you cannot use an output terminal for inputs. The flexibility of Arduino is that you can set each of the pin as an input or an output. Arduino provides that flexibility because there are a limited number of terminals. And this is what needs to be set up in the setup part of the code, as we'll see shortly. Any questions from this part? For the PLC input output, because the inputs are made in a way where each box is set to operate in a particular fashion, they have internal circuitry to prevent the opposite. Because it's industrial, even if there is a polarity reverse, they have a lot of preventive circuits in the boxes, which makes things a little bit complicated, and they also have to cater to particular standards. That is why usually they do not allow this kind of system, because it can create confusion. For example, Bake-Off, they have set procedures for each of these box, and if there are if they allow configurations, it probably is possible from the technological perspective, but probably they just do it in this way because it keeps things simple. And also, like, probably it's also a sales perspective as well. That means they have separate input terminals, separate output terminals, and it's probably a sales thing to keep those things separate, I guess. Okay. Now in a PLC, I'll come to the PLC maybe later on, but for an Arduino-based system, in the setup function, what we usually have to do is, if we are using a particular pin as an input or as an output, we need to define that. So we have to say pin mode, whatever it is, you have to define it as an input or as an output. Also, there is an option of input pull-up. Input pull-up means, thanks, Lip. Input pull-up means it is by default set to 1, and you only can have a 0 to bring it down to 0. That means it's an inverted input. I'm not going to discuss much in the first part of this series on input pull-up, but just remember this is this is inverted input. That means you need to have 0 to make it true or high. Okay, now this pin mode, let's say we are using pin number 2. If you see over here, let me try to zoom it in. You will see that over here, these are marked with numbers. You can see 2, 3, 4, 5, 6, 7. And you can define, let's say, pin mode 2 as an input, and also you can define, let's say, for example, 13 as an output. On the other hand, in a structured text kind of system, you have a block as given over here on the top part. It starts with var for variable and ends with end underscore var. This is a block for definition of variables. And if those variables are linked to an input or output, it is defined in such fashion. Now you'll see that there are two different ways. It says, for the first one, I have made it different just to make it easy to understand. The first one, it has at %i star. The %i stands for input. On the bottom one, it starts with %q, that is the output. Now, if it is mentioned as a star, that means it is flexible. You do not have to hard code the exact pin in the program, but you have the option of linking it outside of the program. I will make it more clear. So let's say if I go back to this picture, let me delete all this. This box over here, I think I can see it is EL1889. This is a Beckhoff inverted input terminal. That, for example, has got 16 inputs. You will see that there are a bunch of cables over here. It has basically 16 inputs. Now, if I mark a variable, let's say B switch at %i star, bool, etc., whatever. This means in the program, I do not hard code what the exact pin number is, but I can actually do it otherwise, outside of the code in some sort of settings. Outside, I can link this variable to any of the inputs. So let's say from this terminal, I choose pin 15 out of the 16, and I can set it up outside of the program. So that means to change a link, I do not have to recompile the program. I do not have to make any changes in the program. My program is independent of the hardware. You can use the same program with a different hardware input switch. That is why nowadays it has become kind of like a norm to use this sort of input linking. On the other hand, that means your hardware port number is fixed. You cannot change it outside of the program. It is hard-coded in the program. As I wrote over here, if you can see, if you use stars, %i means input, %q means output, it can be mapped outside of the program, irrespective of the hardware. Whereas if you put in fixed port numbers, it is hard-coded in the program. You won't be able to change it. And the lower table, this has been taken from Beckhoff. Beckhoff has a very good information systems. This method of IO definition is not only for bake-off, it is also for, as I will show you from another screen of mine. If you search for PLC open, Allen Bradley is typically always different, but PLC open has a number of members, and they include bake-off, Siemens, KUKA, Schneider, and various mostly European brands. And PLC Open has worked closely with the IEEE standard, and they have more or less similar things. Allen Bradley is completely different. Even the function blocks or other functions doesn't match up. But if you look for organizations or companies that are members of the PLC Open, then you will find that they are very close to each other. In fact, they have almost same form of programming. Just look out for PLC Open. You will also find, I will show afterwards in a separate screen. It is on my desktop. I will share it. If you go to their site, they have multiple information to be downloaded. You can download a lot of things from PLC Open. And the function blocks given in the PLC Open website, you will see that if you go to Schneider, Siemens, Beckhoff, Beloff, KUKA, they all have similar structures. Now this table more or less defines what can your settings be. So I with X means you are defining a bit, which is the most common one. But if you use B, W, or D, you can define other larger data types as well. That means you can basically use, for example, 16 bits of an input terminal directly to get an input of 2 bytes. You can directly take inputs of 2 bytes or more using that kind of mapping. Any questions from this page? Okay. Now the examples that I'm going to cover are very simple. It's like one of the basic things that we can have. The first circuit is like a simple on-off circuit where we use a switch to light up a bulb, something like that. The second circuit is a start-stop system, which is similar to, let's say, starting a water pump, or let's say opening or closing a shutter, where you press a button that starts to open the door or shutter, and you press a stop button to stop it. The third circuit has 3 different programs, all of them using the same circuit. The first program being a single button start stop. That means you press a button once to start a motor or something, and you press the same button the second time to stop the motor. The second program is a single button start delayed auto stop. You can think this something like a garage door, or maybe a swipe-in door, where you swipe your card and the door opens and it closes after a certain time, somewhat similar. So you press a button, the motor starts or the output is started, and it shuts down itself after a certain amount of delay. A very basic program, but very commonly used as well. The third one is a sort of sequencing start. That means it has a particular code. In this case, you have to press it twice, to start something, and then after that, you just press it once for a certain number. I just put it 2 and 1 in my program, but this can be something else. Maybe it's up to you. Maybe 5 push to start, 2 push to stop, something like that. It's also possible. Now this one is circuit number 1. As you see in the Arduino setup, a similar thing can also be done in a PLC, but because I will be using Tinkercad to demonstrate the Arduino circuit, this is what I'm going to stick to. The input is connected to pin number 2. Now, because Arduino does not have a dedicated sort of input system, it is a flexible port. Arduino prefers to have a pull down system. That means if you see over here, commonly our on off system, it is like either connected or not connected. For Arduino to have an input of 0, the signal or the input needs to drop down to the ground or 0. That is why we have a pull down register where when the input is not 1, it is forced to bring down to 0. If it is kept floating, there are jitters and the program doesn't work properly. So Arduino requires that you drop a pin down to 0 to make it a 0. This is not required for PLCs. For a PLC, it is on, and if you remove the wire, if it is floating, it is considered as an off. It has internal pull down registers. So this is one of the things, again, Luke, which makes the boxes different, because typically those boxes have either pull up or pull down kind of system, and which hampers a bit of flexibility. Pin number 13 over here is connected to an LED to simulate an output device or a motor. The good thing about Arduino is that in the Arduino Uno board, there is a LED in the board, which is also connected to pin 13. So even if you do not have a external LED or anything, if you try to program pin number 13, what you will see is that for a high output at pin number 13, the LED will glow. For second circuit, I think I'm a little bit short of time, I guess. It's already 36 minutes, so I will go quickly. In the second circuit, there are 2 inputs, and the common output is 13. And in this push button switch, I just wanted to explain this because I had a bit of trouble figuring this one out in Tinkercad. The default path in this, so if you are playing with Tinkercad afterwards, you will have this switch in the CAD, and by default, this pathway is open. And when you press the switch, this pathway opens up. So that means, to make it clear again, if you press it, this is connected. If you release the button, this is connected. So when it is released, there are 4 pins in the switch. When the button is released, the vertical ones are connected. When it is pressed, it is connected in this way. So as you see, this is my plus 5 volt. So when I press the switch, this plus 5 volt is connected. When I release the switch, this pull down resistor is connected. Okay. And in circuit number 3, it is again just one push button switch that is connected to pin number 2. Now, before going further, Let's now move to my other computer. I will share the other screen and show the working of each of them. Can you see this Tinkercad screen? Yeah, okay, thanks. Now you can go to Tinkercad and open up an account. It's free, and you basically can, let me just show a little bit of how it works out. You can go to circuits and you can create a new circuit. And you basically have a bunch of things. So you can actually drag a Arduino. Oops, I dragged twice. You have motors, you have, see, if you see on the left hand side, you have motors, you have sensors. Like it is like the entire Arduino kit just got online. So if you want to try this out, and also I think this is a good thing for teaching, you always don't need to have a kit. You can use this as a trial run first, and then you can always fall back on a kit. And I am finding this particularly helpful to do this webinar. I don't have to carry a hardware kit along. Okay, now let's get back to the demo circuits. Yes, I will be showing some demo with the timers. The one that I have been using, the delayed off, it has got a timer. And the second one, the push button type, like where you press twice to start, it has a timer. Sorry, it has a counter also. So I'll discuss the function blocks for structured text and also how the Arduino works out. Okay, now if I start this simulation, the code can be written here. So if we press this button, we have the code that can be written. And it's simple. It's like you turn on the switch, it glows, and it turns off when the switch is off. That's the first circuit. I will quickly show the other two and then come back to my other screen for the code. Now in this case, I press one of the buttons to start. I press the other one to stop. And for the third circuit, there are three different programs for the same circuit. The first one, it has got okay, I think I messed up one of my codes. Yeah, for some reason, Tinkercad doesn't allow the interrupt function to be at the bottom. So I have to bring it on the top. Okay. So it is like single button push to start and push to stop. So that was circuit 3 program 1. This is circuit 3 program 2. To save time, I'm showing all the demo first, and then I will get back to my surface with the codes. So in this one, I press once to start, and it will shut down after 10 seconds. You will see that there is a time over here, simulated time. And that shut down automatically. Here's the long code. I will discuss it on the surface. And the third one is 2 push start, 1 push stop. It is again using the same circuit, but just the program is different. I press once, I press twice, it starts up, and again now when I press a third time, it stops. Again, 2 press start, single press stop. Okay, now let me quickly go back to the surface. Now for the first circuit, in Arduino based system, I have to, this is not mandatory. I could have just used 2 and 13 directly, but it is kind of like programming convention to define the pin numbers first. So I define a pin number. Constant is being used so that it cannot be changed later in the code. Int I on off switch is equal to 2. That means I'm using the switch at pin number 2, and I am using pin number 13 for output. Now, as I was discussing before, the setup part of Arduino is being used to define which pin will be used as an input and which pin will be used as an output. Now, there are 2 ways a program can be structured. For simple programs, it can be either straightforward Boolean logic or it can be a state machine. Now, the first example is a straightforward Boolean logic. That means it is not complex, it's a 1:1 relation, but here it is defined as the B motor out. That means the output variable is straight away connected to the input variable, and that is being written. So depending on the input variable, the output variable changes, and the last line of the code basically continuously writes. Digital write is basically the output button, or not the output button, it's basically a function defined by Arduino where you declare the output state as on or off. So the first part is the pin number. The second part is the state. So if this is 1, that means the state is high. If this is 0, the state is low. The second program basically does the same thing, but it does in a fashion of state machine. The input is first stored, but then there is a if-then condition where depending on the state of the variable, the output state is written. If B motor out is true, then the output is set as true, else it is set as false. So it's like a very simple state machine. The ladder program, on the other hand, is again very simple. Of course, I guess everyone has done some sort of ladder programming, but if you have not, the switches are displayed in this fashion. Sometimes you have inverting switches, which are like this. That means it is also known as normally connected, and this sort of switch is known as normally open. And sorry, normally not connected, it's normally closed. And the outputs, these are also commonly known as contacts, and these are also known as coils. State machine, Nathan, in ladder is very difficult, and that is why we are all moving towards structured text. I have done both ladder and structured text, and I have a very hard time writing like a 200-page long ladder program. Again, the writing part is easy. Maintaining a ladder program is the most difficult part. And one of the programs that I wrote, I pray that no one communicates to me about that program. Simple. It's like I was talking to a colleague and he was saying that we haven't heard from that project for a long time. I said, just don't even talk about it. Ladder, it's easy if it is straightforward Boolean logic. Sometimes you can do a bit of state machine type using ladder. I will show in one of the examples, but it becomes difficult over time. Okay, now let me get back to where I was. On the structured test again, so if it is a straightforward Boolean logic, where you can directly assign the output to the input, or if this has got anything else like and, or you can also write it up directly. And a state machine type of system can be used in this fashion. I have all these codes, so if you want these codes, I can email that to you afterwards, just as a text or picture. And you can go through them afterwards. Let me go to the more complex part of the circuits. Now in circuit 2, it's a one push start and one push stop. I will use the ladder first. So here, this B motor out is also used as a latch over here. That means once B motor out is true, this latch will keep it true over time. By default, this is normally closed. That means once you start this button, that means when this gets connected, this entire row will be true, and that will start up. Once that starts up, that means once in the instance B motor out gets true, this latch will be true. That means irrespective of the start button being turned off, this will still hold true. As long as this B stop is not pressed and it doesn't shut it up. Once it is shut up, this will become false. That means this will also become false, and the circuit is broken. Things are a little easy when it comes to the standard program, both for Arduino and structured text. Now here, we have defined the input and output switches. In the scan cycle, what happens, digital read is again a function that helps us to read. This is one of the differences again between PLC and Arduino. In a PLC, once a variable is mapped with the input or output, the value of the variable is constantly synced with the actual hardware. On the other hand, in Arduino, it is not constantly synced in the program, you have to typically use a digital read function to read the hardware in every cycle. By default, it is not synced. One of the drawbacks is that this digital read function, it takes a lot of time to run and it kinds of slow down. In a particular scenario, I think I saw that there are custom read functions which are much faster than digital read, and it's widely available over internet. So if you are doing any project with Arduino that needs fast read, you can look over there for the codes which does not use digital read function. But anyway, so over here, first of all, this value is read, and if it is true, then it starts out B motor out is equal to true, and in a separate condition, it reads again the stop switch, and if the stop switch is true, it sets B motor out is equal to false. As simple as that. And the last bit, it is continuously being run. So depending on the state of B motor out, either being true or false, the output relay variable is set to true or false. Similar thing occurs in the structured test as well. Now over here, I basically wrote two different types. Now, first of all, this one is state machine based, and this one is Boolean logic based. The same thing can be done in structured text as well. This is what the ladder is about. So if you transfer this ladder logic into a Boolean logic, this is what you get. So you see, not the first part, not B stop button, it's basically this one, and B motor out or B start button, it's basically this one. So when you have this in parallel, it's basically an OR logic. So it's the same thing. The ladder is being converted to a Boolean logic, and it is being set to the output variable. This can be done in Arduino as well. In Arduino, because it follows the C, similar to C, the notations and syntax, and is double ampersand in the keyboard, and this is the double pipe sign on the keyboard. Whereas in structured text, you just type in AND or OR. The state machine type, as discussed previously, can also be done in structured text. It's a if-then scenario. Any question with this circuit? Okay, I'll quickly try to go to, it's already 3. Hopefully you'll spend some more time with me to finish this up. In the third circuit, it is single button start and stop. You press once to start it, you press twice, I mean not twice, you press it one more time to stop it. This complex ladder logic I am not going to discuss because it's going to take time, but it is basically a complicated Boolean logic to get that scenario. And you'll see how things get easier in Arduino and structured text based programming. Now, if you see, in this case, we are using an interrupt in Arduino, and we'll use a trigger in structured text. This function, attach interrupt, if you want details of it, you can go to the Arduino reference, can be set. So this first part is the pin number. Second part is the function that need to be called when an interrupt is called. And the third one declares in what kind of situation the interrupt need to be called. It can be rising. There are other options like falling, change, that means it the interrupt is triggered in both ways. It can be like either rising or falling. You can go to the reference and see the different types. In this case, we are using rising. That means the interrupt is going to be triggered when for the switch there is a rising edge of a pulse. And what happens in the interrupt? So this is the interrupt part of the code where it says that if the motor was turned off, let me zoom it up a little bit so that you can see. Yep. This not sign means that it is inverted. That means in the if condition, it says that if not B motor out, or we can write it in other words as if B motor out is equal to false. So if it is false, the interrupt makes the B motor out is equal to true. And if it is true, then it makes B motor out is equal to false. So you see, it becomes such simple, where in ladder logic we have to deal with a very much complex logic. And in the loop part, only function that has been called repeatedly is this digital write, which basically sets out the output pin depending on the status of B motor out. The interrupt does most of the job. In structured text, we have to emulate the interrupt in a different way. We don't have interrupts in structured text, but we can use function blocks that are used to emulate that. The rtrig is a function block, and we are defining FB rtrig as an instance of that function block. And what does rtrig does? Let me try to explain quickly. Rtrig triggers an output. Let me make a plot. Now, if the user input is like this, let's say someone pressed a switch and then release it. Now, of course, human hands, they take longer than the scan cycle of the PLC. And let's say, just for the sake of understanding, this is the time period of the PLC scan cycle. That means after each of this time period, the program starts to run in a repeated, or I mean, the program is being repeated. Now, for an rtrig function, what happens is once there is a rising edge, the Q part, it has got an input and it has got an output. If this is the clock, the output of the rtrig function block, it will be triggered at that moment. It will remain high for the rest of the scan cycle, and then it will fall back to zero. That means even though the human hand is slow to release the button, that won't be, this Q won't be triggered unless, let's say, at this point another press happens, the queue will be on only at that point in that particular cycle. So this is a way to emulate an interrupt. That means in a particular scan cycle, if there is a rising edge for the switch, the queue output of the function block will go high, but it will stay high only for the rest of the cycle, not after that. The F trig function block is basically the reverse of R trig. So R trig, R stands for rising, F stands for falling. Now in the program, what we are doing is, first of all, we are defining a function block FB R trig. Now this function block instance need to be called in every cycle because it is monitoring, it's acting or it's emulating an interrupt kind of system, and that is why it need to be called in every cycle, because it is keeping a note or tab for the push button to be active. Now once this queue gets high, that means there has been an instance where this is being high. Now you can allow the state machine to decide. The state machine is also being run in every cycle, and it decides based on the fact of the state. So if B push button, that means if this output is true, that means in one particular cycle it has gone high and the motor was false previously, the motor starts up. On the other hand, if there is another push and the B motor was already high, it stops the motor. I will send you these programs if you want, and you can go through it afterwards with your own time and see how this works out. But it's basically each time a key is pressed, the state machine is activated. So it can either be on, this is I'm talking about the motor, or it is off. Now depending on the present state, it is going back and forth. So if motor is on and Q becomes high, motor is turned off. And if motor is off and Q becomes high again, so let's say Q is equal to 1, Q is equal to 1, it comes back to the other state. That's the state machine. And in this bottom part, I have created another ladder program which uses the same function block FB tree. So instead of this complicated ladder shown above, you can also use in modern PLCs using this FB tree function block. And I think, Nathan, as you were asking, how does the state machine work? So this state machine over here is implemented in a ladder-based system in this part. So if you see these 4 cases, there are 2 state variables which are being set and reset. This is being used to kind of formulate the state machine in ladder. Chris, yes, I'm recording this at present, and I will put it up over somewhere. Maybe I will send an email to all of you with the recording if you want. Any questions from this part? Okay, moving on. In the delayed auto stop, we will use another function block of timer, but let's go through the simple Arduino program first. Actually, the Arduino program is not so simple, but okay, we can deal with it. Now again, in this Arduino program, an interrupt is being used, which is a button pushed interrupt, and this interrupt is usually called when the switch goes on with a rising edge. And what does the interrupt do? The interrupt basically changes the state of B button pushed is equal to true. And what is the purpose of that button? If the button when true, this condition is satisfied and there are certain variables used for time. Now millis is a function in Arduino that provides the number of milliseconds the Arduino has been on since it is switched on. It returns a value which is of type long. That is why long means in Arduino the data type is given, it can store a very large value. So as you see over here, the previous time and the present time, it is set as 0 and they are of type unsigned long. Now when this button press or button pushed variable becomes true, the previous time is stored as the present time. That means, let's say when this program is running, it holds the value of certain milliseconds and it turns the B motor out to be true. Now the present time keeps on storing the present millisecond, but in the next scan cycle, this is no longer, the if condition is no longer satisfied. So the previous value holds the last time when button pressed was true, and present time it is holding the time in milliseconds in all the scan cycles. And now there is a condition: if the difference in present time and the previous time is greater than the delay, in our case it is set as 10 seconds, the motor is turned off. And then there is this function digital write, which continuously keeps on pushing out the status of B motor out in the output pin. What happens in the, I will define the structured text program first. The ladder program is basically made, so to be honest, what I did is I wrote the structured text program first and then I modified it to the ladder, because using these function blocks, it's easier to think in terms of structured text than using the ladder. It makes things much simpler. Now over here, we are now using the R trick that we discussed previously, and we are also going to use a timer function. Now how does that timer function work? In a timer function, there is a in, there is a PT, which stores how much time. In our case, it is 10 seconds, and then there is a Q. So when in becomes high, the timer starts counting, and Q will only be high when that time 10 seconds have crossed. And then it will become low as soon as the scan cycle ends. It will only become high, let's say, after this has gone low and gone high again after a certain amount of time. So the timer is basically triggered when there is a rising edge at in, and it will again be triggered after the timer has counted down. It will again be triggered when this input pin goes high again. So in the structured text, what we are doing, this timer, it has an input of B motor out. That means the rising edge trigger for this timer is when the motor is started. So as soon as the B motor out goes high, the timer will start up, and after 10 seconds, it will, or the B timeout variable will go high and remain high for the rest of the cycle. So the state machine says, if my present situation of motor is 0, and I have a trigger that B button pushed is equal to true and motor out is equal to false, that means the condition given over here, my motor is turned to 1. As soon as this becomes 1, the timer is also triggered, and it will count down up to 10 seconds, and then Q will become high. Once Q becomes high, what it will do, it will automatically trigger this B timeout button, and if that becomes true and B motor out is already true, B motor out becomes false. So that is the state machine over here, which is being used using a timer. The ladder program is basically just copy paste in terms of, like, I basically used the same logic to create the ladder just for the sake of creating the program. But I thought the entire process in the structured text first, because this kind of things is easier to write in structured text than the ladder. You can go through this ladder program if you're interested afterwards, but because of the short of time, I'll just keep it for the time being. And for the last part, where we have a 2 push start and 1 push stop, we are using a CTU function block. CTU is count up, CTD is basically the reverse, it is count down. We are using a up counter where there is a CU and there is a Q. The Q will only get high, and PV basically stores the number of count we are trying to do. So that means if PV is set to 2 and this is CU, once you have 2 rising edges, the Q will become high and remain high for the rest of the cycle. The difference between the other function blocks that we did is that this counter has to be reset. So this Q and the CU is not going to reset unless the R or reset is going high and coming down. So the reset button has to go high and fall back to 0 to reset the counter. So you can again use the counter only when your reset has been gone 0, 1, 0. It has to be 0, 1, 0 to reset the counter. Now let's come back to the program. With respect to Arduino, I will just discuss what I'm doing with the interrupt. In the interrupt, in Arduino, when there is a push button, I'm just incrementing a variable. So if you have done some sort of program, you will know that this plus plus denotes +1 and minus minus is -1. The counter is being incremented, and in the state machine of Arduino, what I'm doing is that again, if not B motor out, that means if the output of the motor or the output pin is 0 and counter is equal to 2, that means there has been 2 calls of this interrupt. It starts the motor and it resets the counter to 0. So the counter is fall back to 0. On the other hand, in another separate condition, if the motor is already running and if the counter is 1, that means the interrupt has been called once since it was reset previously, it will trigger the output to 0, and it will also reset the counter to 0. And then there is this digital write function which is constantly checking out the status. Again, as I discuss, if those join later, please put your name and your organization for the record. Mohammed, if you can note down the names for the attendants to file the report. Thank you. And for the structured test program, here we have the FP counter, again being called in separate instances. So what we have done, we have used 2 different counters because we are not having an interrupt form of system. What we have over here is emulated form of triggers. We have to use 2 separate counters. The reason is that one of the counters is set to 2 and the other counter is set to 1. That is why we have to use 2 instances of the counter, one for counting 2, the other one for counting 1. And these instances are called inside the conditions of the state machine. And the trigger is of course there. The trigger takes care of the input switch as we have seen previously. Now what are the conditions are? If B motor out is equal to false, that means the motor is off already. This counter is waiting for the button to be pressed. And if the button is pressed, it keeps counting, and this will be true only when there are 2 counts. And if that becomes true, the motor is turned on. I think I'm making things clumsy. Once the counter 1 is true, the motor is turned on, but as we have seen that we have to reset the counter, and that is why we have to go, so the reset button needs to go 0, 1, 0 to reset the counter. So first of all, we are calling that function block again with the reset button as true. Now, one thing I forgot to mention before is that when you are calling this function block instance, you don't have to put all the input or output variables, but if you need something, you can call with that. So unlike a C or Arduino type of function where you always have to use all the parameters, over here, if you look, the parameters are different. So if the parameters, in this case R for this one, is not mentioned, it is not activated. We are only using the parameter when we need it. And in this case, we are requiring the R button. That is why we are calling the function block with the input. And we are also using this parameter so that when R is true or the reset button is true, this variable will also be reset. And then in the last call, we are just calling with R is equal to false. That means R goes from 0 to 1 to 0. Now the counter is reset. So this is a little more complicated than the Arduino, where you could just use a single counter variable. But because Arduino has interrupt and this one doesn't, that's how we have to deal with it. Now, if the motor is already running, that means this else is activated when the motor is already running. There is a separate counter which keeps on counting the number of button pushed, and in this case it is 1. It's up to you how much you want to set it, but I'm explaining this with respect to 1. And once that counter is satisfied, that means in this condition, the output button is set to false, and again we have to reset the counter, which is done in the last 2 bits of it. Now, to be honest, I tried to write the ladder program for this one, but I thought it's taking too much time to finish it. So I would keep it to the structured text and not decide and not discuss any form of ladder, because these programs that include a lot of function blocks and stuff, it is much easier to write in structured text than in a ladder. I think that's where we kind of end. If you want, I can send you this program so that you can look at it with your own time. I know I have skipped a bunch of things that might need a little bit of explanation. But if you want to ask something at this point, please feel free to ask me. Any questions or any doubts? Thank you, dear. Before ending this, I just want to show one other thing, that is this PLC Open website. If you are interested in going through the details of IC standard programming, and also like what are the details, PLC Open has got many guidelines and downloads that you can get it for free, and it will help you to kind of self-learn many different aspects of this IC standard programming. And the Arduino reference is available. It is again in their website, all the functions that can be used. Not only because I use Backoff, but I also find that for most organizations, the information are proprietary and it is not easily available, but Backoff has a policy of keeping the information free to all. Even their PLC software is free to download. You don't need a license. I mean, you need a temporary license to run, but it is free to download. And all these types, different things, aspects of structured text programming or ladder programming, they are available in the Backoff information system for free. Everyone can access this. Thank you very much, Chris. Thank you everyone for joining in. I hope that's probably the end of it. I will try to make a sequence to this again afterwards, which much more details and a little bit of serious stuff than this. One of you requested me for a PID program, which I could not show in this one, but maybe in the future I will also try to do a PID loop using both PLC system and as well as an Arduino system. And anything that you have in mind with respect to this series, you can email me so that I can keep it in mind and put down in the next webinar series. Thank you very much. I'll end this meeting now. Goodbye. Thanks.